In the final years of the Second World War, as Allied forces closed in from both east and west, Nazi Germany unleashed a weapon unlike anything the world had seen. Rising from launch sites across occupied Europe, the V-2 rocket screamed through the stratosphere at speeds exceeding 3,500 miles per hour. These were not merely missiles. They were humanity's first objects to touch the edge of space. The question that has occupied historians, engineers, and strategists for 8 decades is not whether the Nazis achieved this technological leap, they demonstrably did, but rather what it meant, what it cost, and how close they truly came to realizing the full potential of spaceflight. This is the story of the Nazi rocket program, a convergence of scientific ambition, military desperation, and human suffering that would reshape the trajectory of the 20th century. Origins. The roots of Germany's rocket program stretch back to the 1920s, long before Adolf Hitler's rise to power. In the aftermath of the First World War, the Treaty of Versailles had severely restricted Germany's military capabilities. Artillery, aircraft, and submarines were all limited by explicit terms. But rockets, primitive, unproven, and largely theoretical, were not mentioned. In 1927, a group of enthusiasts formed the Verein für Raumschifffahrt, the Society for Space Travel. Among its members was a young engineering student named Wernher von Braun. These were not militarists but dreamers, inspired by the science fiction of Jules Verne and the theoretical work of pioneers like Konstantin Tsiolkovsky and Hermann Oberth. They conducted experiments with liquid-fueled rockets in abandoned military facilities, achieving modest successes and frequent failures. The German army took notice. In 1932, Captain Walter Dornberger of the Ordnance Department attended a demonstration of the Society's rockets. He recognized immediately that this technology, if developed properly, could circumvent the restrictions imposed by Versailles. More importantly, it offered something conventional artillery could not: the ability to strike targets hundreds of miles away with virtually no warning and no defense. Dornberger recruited von Braun, then just 20 years old. The transition from civilian experimentation to military program was swift. By 1937, the operation had moved to Peenemünde, a remote facility on the Baltic coast. It would become one of the largest research and development centers in the Third Reich, eventually employing thousands of scientists, engineers, and technicians. The objective was clear: develop a long-range ballistic missile capable of delivering a 1-ton warhead to targets in Britain. The path to achieving this objective was anything but clear. Technical achievement. The engineering challenges facing von Braun's team were formidable. No one had ever built a rocket capable of the performance requirements the military demanded. The weapon system they envisioned would need to accelerate to supersonic speeds, reach altitudes of over 50 miles, and then plunge back to Earth with sufficient accuracy to hit a city-sized target. Early attempts were catastrophic. Test rockets exploded on the launch pad, disintegrated in flight, or tumbled out of control. Each failure required months of analysis and redesign. The engineers were working without precedent, inventing solutions to problems that had never been encountered. The breakthrough came on October 3, 1942. Rocket number A4, later redesignated the V-2, lifted off from Peenemünde and performed flawlessly. It reached an altitude of 53 miles, well beyond what would later be defined as the boundary of space, and impacted its target area 118 miles downrange. Dornberger reportedly declared, "Today the spaceship has been born." The V-2 that emerged from these years of development was a remarkable machine. Standing 46 feet tall and weighing nearly 14 tons at launch, it was powered by a liquid oxygen and ethanol engine producing 25 tons of thrust. Its guidance system used gyroscopes and an analog computer to maintain trajectory. The entire vehicle was an integrated system of pumps, valves, turbines, and control surfaces operating in precise coordination. From a purely technical standpoint, the V-2 represented a quantum leap. It was the first long-range guided ballistic missile, the first artificial object to achieve hypersonic flight, and the first man-made object to reach space. The engineering principles it embodied would form the foundation of all subsequent rocket development, both military and civilian. But the V-2 was not conceived in a laboratory divorced from the realities of the Third Reich. Its development was inseparable from the regime that created it. The human cost. In August 1943, British intelligence learned of the rocket program through reconnaissance photographs of Peenemünde. The Royal Air Force launched Operation Hydra, a massive bombing raid that killed hundreds and temporarily disrupted development. Hitler, who had been skeptical of the rocket program, now ordered its acceleration and dispersal to underground facilities that would be immune to air attack. The solution was Mittelwerk, a vast underground factory carved into the Kohnstein mountain in central Germany. The facility would be constructed and operated using concentration camp labor. Thousands of prisoners from Buchenwald and other camps were transferred to a new camp called Mittelbau-Dora, established specifically to support rocket production. The conditions at Mittelbau-Dora were among the most brutal in the concentration camp system. Prisoners worked 12-hour shifts in the cold, damp tunnels, excavating rock and assembling rockets. They slept in the tunnels initially, without sanitation or adequate food. Beatings were routine. Summary executions were common. Disease was rampant. The exact death toll at Mittelbau-Dora remains uncertain, but historians estimate that at least 20,000 prisoners died there between 1943 and 1945. Many died from malnutrition, disease, and exhaustion. Others were killed for sabotage, real or imagined, or simply because they could no longer work. The V-2 itself killed approximately 9,000 people when used against Allied targets, primarily in London and Antwerp. The arithmetic is stark. More people died producing the V-2 than died from its use as a weapon. Von Braun visited Mittelwerk repeatedly and was intimately familiar with its operations. After the war, he would claim ignorance of the conditions there, a claim that has not withstood historical scrutiny. He was a member of the SS, though whether this was voluntary or coerced remains debated. What is not debatable is that he was the technical director of a program that consumed lives on an industrial scale. Military effectiveness. The first V-2 was fired in anger on September 8, 1944, striking Paris. That same day, another hit London. Over the following 7 months, approximately 3,000 V-2s would be launched against Allied targets. As a weapon, the V-2 was a failure. It was inaccurate, with a circular error probable of several miles. It carried a relatively small warhead for its size and cost. Each rocket required scarce resources, particularly alcohol and liquid oxygen, that could have been used elsewhere in the German war economy. The program consumed resources equivalent to producing 24,000 fighter aircraft. Moreover, there was no defense against the V-2, but this was a hollow advantage. The Allies had achieved air superiority, and strategic bombing was devastating German cities and infrastructure far more effectively than the V-2 campaign. The rocket's psychological impact was significant. They arrived without warning, making air raid sirens useless, but they did not alter the strategic situation. Hitler had hoped the V-2 would be a wonder weapon that could turn the tide of the war. It was not. By the time the program reached operational status, Germany was already losing. The rockets were symbols of technological achievement deployed in service of a collapsing cause. Yet the military judgment of the V-2's effectiveness must be distinguished from its technical achievement. The weapon failed not because the engineering was inadequate, but because it was the wrong weapon for Germany's strategic position in 1944. A weapon that takes years to develop and vast resources to deploy is of limited value when one's country is being overrun. The space question. How close were the Nazis to space? The answer depends on how the question is framed. If space is defined as the Kármán line, the boundary at 100 kilometers altitude commonly used today, then the V-2 reached space routinely. The rocket achieved altitudes of 176 kilometers during tests. It was objectively a space vehicle, albeit one designed to return to Earth in the most destructive manner possible. If the question is about achieving orbit, the answer is more complex. Orbital velocity at low Earth orbit is approximately 7.8 kilometers per second. The V-2 achieved velocities of approximately 1.6 kilometers per second. Reaching orbit would have required roughly 5 times the energy, necessitating a much larger rocket or multiple stages. German engineers understood this. In the final years of the war, design studies were produced for intercontinental ballistic missiles and even orbital rockets. The A9/A A-10 was a two-stage design intended to strike targets in the United States. On paper, it could have reached New York. The A-11 and A-12 were theoretical designs for 3- and 4-stage rockets that could have achieved orbit. None of these advanced designs progressed beyond the conceptual stage. Germany lacked the time, resources, and strategic situation to develop them. The A-9/A-10 was tested once, in January 1945, and failed. By then, Soviet forces were less than 300 miles from Berlin. But the theoretical groundwork was there. The engineers at Peenemünde understood staging, understood guidance, understood the thermodynamic problems of re-entry. They had working turbopumps, gyroscopic systems, and supersonic aerodynamics. They were not decades away from orbital capability. They were years away, perhaps 5 to 10 years under peacetime conditions with adequate funding. The Third Reich did not have 5 to 10 years. It had months. Aftermath. As Allied forces advanced into Germany in early 1945, both American and Soviet intelligence teams raced to capture rocket technology and personnel. The Americans, in Operation Paperclip, successfully secured von Braun and approximately 1,600 German scientists and engineers. They also captured enough V-2 components to assemble approximately 100 complete rockets, which were shipped to the United States. The Soviets, arriving at Peenemünde and Mittelwerk after the Americans, captured production facilities, documentation, and several hundred German specialists who had not fled west. Both superpowers recognized that the future of missile technology, and by extension, space exploration, lay in the work begun at Peenemünde. Von Braun and his team were relocated to Fort Bliss, Texas, and then to Huntsville, Alabama. There, they continued their work, now for the U.S. Army. The V-2s captured in Germany became the foundation of American rocket testing. They were launched from White Sands Proving Ground in New Mexico, contributing to American understanding of high-altitude atmospheric conditions and rocket behavior. The moral complexities of Operation Paperclip have never been fully resolved. The U.S. government made a deliberate decision to overlook or minimize the involvement of German scientists in war crimes and crimes against humanity. Von Braun became a celebrated figure in American culture, appearing on television and advising Walt Disney on space-themed programs. His past was sanitized, relegated to footnotes if mentioned at all. He would go on to lead the development of the Saturn V rocket that carried American astronauts to the moon. The engineering lineage from the V-2 to the Saturn V is direct and undeniable. The first object to reach space and the rocket that enabled humanity's greatest space achievement share a common origin. Legacy. The Nazi rocket program exists in history as a paradox. It represents both the heights of human ingenuity and the depths of human cruelty. It achieved what had been thought impossible while being built on the corpses of slave laborers. It changed warfare, changed spaceflight, and changed the course of the Cold War, all while failing to achieve its immediate military objective. The technical legacy is clear and measurable. Every space program in the world traces some lineage to the work done at Peenemünde. The basic architecture of the V-2, a single-stage liquid-fueled rocket with gyroscopic guidance, became the template for the first generation of missiles and space launchers. The R-7 that launched Sputnik, the Redstone that carried Alan Shepard, the missiles that formed the nuclear arsenals of the superpowers, all were descendants of the A-4. The moral legacy remains contested. Some argue that the scientific achievement should be separated from the political and moral context in which it occurred. Others argue that such separation is impossible and that the glory of technological progress must be weighed against the cost at which it was achieved. The historical record provides no simple answers. The scientists at Peenemünde were not all true believers in Nazi ideology, but neither were they passive innocents. They made choices: to continue working, to accept slave labor, to prioritize technical achievement over moral consideration. Some made these choices enthusiastically. Others made them with varying degrees of reluctance or rationalization. The result was the same. The Nazi rocket program came close to space, not metaphorically or aspirationally, but literally. The V-2 reached space. It did so in 1944, 13 years before Sputnik, 17 years before Gagarin. It achieved this not through serendipity but through systematic engineering effort, backed by industrial resources and built on human suffering. Whether Germany could have achieved orbit before the war's end is counterfactual history. What is factual is that the technical foundations for orbital flight were established at Peenemünde. The engineers understood what was required. They had begun designing the systems that would be necessary. They lacked only time and resources, commodities that the dying Third Reich could not provide. The program's importance lies not in what it achieved during the war, but in what it enabled afterward. The Cold War space race was built on German foundations. The geopolitical balance of the nuclear age rested on delivery systems derived from German designs. The dream of space exploration, realized in the decades after 1945, was launched from drawing boards first used in Nazi Germany. This is not a comfortable history. It forces confrontation with the reality that scientific progress is not morally neutral, that achievement and atrocity can be intertwined, and that the future is often built from materials shaped by the worst aspects of the past. The Nazi rocket program was simultaneously a marvel of engineering and a monument to barbarism. It reached space while standing on a foundation of bodies. It opened the door to the cosmos while serving a regime dedicated to conquest and extermination. It achieved the impossible through methods that were unconscionable. History does not allow us to celebrate the achievement without acknowledging the cost, nor to condemn the methods without recognizing the significance. The V2 reached space. That is a fact. What we make of that fact, how we remember it, how we teach it, how we allow it to inform our understanding of science, progress, and human capability, remains an ongoing choice.